right, so let's take a look at different kinds of soils. You know, scientists, we love to classify things. Just remember, if you ever took a biology class, remember you classified life in kingdom, phylum, class, order, and all that good stuff. Well, soil geologists do the same thing. They have orders of soils and families of soils and series of soils. And if you really, really want to learn all of those different types of soils, take a soils class. Or you can look on this website. And this is the U.S. Department of Agriculture's website of how different soils are classified. I'm just going to run through the basic types of soils, not all of those little subsets of them. And we'll just take a look at how they're different and why they're different. And so anyway, the classification of soil is called soil taxonomy. And one of the types of soils we have is called an alpha sol. And an alpha sol is acidic, and it's a very clay-rich soil. So it has a lot of those little fine-grained clay-sized particles in it. And these often develop under a hardwood forest. And that's why when we look at the distribution of these alpha sols, we can see they're in places where we have these hardwood forests. And they make up about 10% of global ice-free land area. Now that's alpha sols, and this is what one would typically look like. There you can kind of see those different horizons and how they have some different colors. Now, we also have a soil called an andesol. Andesols are soils that develop on volcanic material. And that's why we see them, say, up here in the Pacific Northwest of the United States, where there's volcanoes, parts of Alaska, where there's volcanoes, parts of Mexico, Iceland, and the Andes Mountains. These develop on those volcanic materials. And again, this is what a typical andesol, what the different horizons look like. Aridosols are soils that develop in desert environments, right? We even see the word arid in there. So this is going to be in dry climates. And aridosols very often contain minerals that normally are extremely soluble. Things like calcite, gypsum, or halite. Halite is simply salt, like the table salt that you use. Which is very, very soluble in water, but in some places it's dry enough and there's just not enough rainfall to wash these minerals away, so instead they're able to accumulate in the aridosols. And since these are desert soils, well, these we're going to see in places with arid climates, like parts of the western United States, parts of the Sahara, parts of Australia, and so on. And this is a typical aridosol. Oftentimes you'll see a lot of white or pale color in that aridosol. That's some of those soluble minerals that are building up. Entosols lack horizons. So this is a soil that you're not going to see these really, really distinctive different layers in it. Here's the distribution of entosols. We can see there's a lot in the Sahara and parts of Baja, Mexico, parts of Australia. And there you go, you just don't see a lot of layers. And that's because these tend to be relatively young and have not developed that much yet. Gelisols are soils with permafrost. Permafrost is basically year-round ice staying in the soil. So these are going to form in polar locations where it stays cool enough that the soil does not thaw in the summertime, or at high altitudes. So we see a lot of these permafrost soils in parts of Canada, but also in really high mountainous areas, like over here in the Himalayas. And this is what one looks like. The top part of the soil might not be frozen and might not have ice in it, but down here, that's all ice in that soil, and that ice stays there year-round. Histosols Oxisols are wetland soils. They form in kind of swampy and boggy areas. And they're going to have a lot of organic material because in areas with stagnant water, organic material does not decay, and so it builds up. And so you'll end up with these soils in some places that you would expect. You see a little green right there in southern Louisiana and southern Florida. Well, those are swampy areas. But interestingly, you see a lot of these also in more northerly climates. And that's because places that used to have glaciers covering them often have lots of swampy areas. So they're going to have a lot of these soils. This is what one looks like. Remember I said earlier that dark colors correspond to lots of organic material. There you go, dark soil because of that high organic content. Inceptosols are weakly layered soils. So these again are quite young and the soils have not really developed that well. And we can see in pink the distribution of these inceptosols. And this is what one might look like. We have can weakly make out an A and a B layer in there, but it's not as distinctive as in other soils. Mollisols are grassland soils, and these tend to have a nice thick humus-rich layer. Remember, humus is partially decayed organic material, and it can also make the soil very nutrient-rich. So oftentimes these mollisols are great soils for agriculture. And we see, I said it was grassland soils, so we see a lot of these in the Great Plains, the prairies, and also in some of the grasslands of Asia. And this is what one looks like. Notice that dark, organic, rich color, but we do see these other horizons developed in it. Oxisols are highly weathered soils. They're not very nutrient rich, not very fertile, and these tend to form in more tropical areas, places where you have lots and lots of water that's going to basically wash away all of the nutrients. And that's why we see these forming, for instance, where we have the Amazon rainforest or some of the rainforests in Central Africa. And this is what they look like, right? We don't see much of an organic layer there, mainly because those organics get removed very quickly in that tropical type environment. Spodosols are acidic soils, and they do have significant leaching. Hey, there's a typo. They have significant leaching, which means there's plenty of water passing through these, removing some materials. And these tend to form in boreal forests. That means forests that are more northerly. They're more towards the polar areas. And these are common in coniferous forests, where you have lots of pine trees and spruce trees and things. And so that's why we see these in these more northerly areas. And this is what they look like. Again, you have some nicely developed horizons in that soil. An ultisol is highly weathered and very well developed, and it's typical of warm and humid climates. That's why we see those in the southeastern United States and right here in parts of Texas. Warm, humid type climate. And this is what one of those would typically look like. And then we have vertosols. These also are found in areas actually right here around Houston. Vertosols contain swelling clays. Swelling clays are special types of minerals that can absorb water. And when they absorb water, they actually grow. They swell up, and then when they dry out, they shrink. So this soil is always kind of changing its volume depending on how much rain has fallen. So we see a little sliver of some of the vertosols around here in Texas, but we can also see they exist in some other parts of the world as well. And this is what they look like. They often do look kind of chunky and blocky because they are constantly shrinking and swelling in response to water. All right, so now that we have kind of a basic idea of what some of the different soils that exist are, let's look at some problems with soils and see, you know, like what do we have to account for? What issues might we face dealing with soils? Well, soil erosion is a big issue, and soils form very slowly. You can see, I mean, fractions of a millimeter per year. Tiny, tiny amount per year forms. Erosion is usually much, much faster than formation. So that's telling us in some places soil is practically a non-renewable resource. It's something that we're using up faster than Earth is making. So we really want to limit soil erosion so our agriculture doesn't suffer. Most erosion is caused by wind and water. Wind and water remove this soil from the surface. And as a result of erosion, you might have a reduction in agricultural yield. And I found this study that was conducted in Tennessee, this is probably a 20-year-old study now, but when 6 inches of topsoil was eroded from an area in Tennessee, the corn that was grown, 40% less corn. So that's 40% less crops produced when we had just 6 inches. What is that? Is that about 6 inches? That much soil erosion. So this can be significant, especially when we have such a huge population in not just the United States, but the world, who all of them got to eat. Another problem with soil erosion is sediment pollution. That soil that's eroded off of the farm fields and things, it does have to go somewhere. And oftentimes it fills stream channels. And that's what we're seeing here. Normally all of this soil would not be there in the stream channels, it would be in the farm fields over there. And this can have big ecological effects because maybe the plants and animals that are living in that stream, they need clear, clean water. If suddenly we're getting a lot of soil in it, it's not going to be clear and clean, and that could kill some organisms. On top of that, this is going to make flooding worse because now this soil is occupying space where water should be. So sediment pollution can be a bad thing from soil erosion. And then also, soil erosion can result in some toxic residues building up in the soil. Well, these toxic residues come from pesticides and herbicides that are used by farmers. Pesticides kill like bugs and things. Herbicides kill weeds. Well, how does this happen? Well, when you lose nutrients in the soil, that reduces microbial activity. It reduces the activity of the little bacteria and fungi and things, and those actually break down the toxins. So it's this sort of chain reaction of if we have less of this microbial activity, then we have less of those breaking down the toxins, and so then the toxins can build up in the soil. And then of course we can have dust storms. And I often say, like, how can, you know, I've said many times, Earth is trying to kill you in here. And in fact, dust storms can be deadly. During the Dust Bowl of the 1930s, many people who lived in the Great Plains suffered from something called dust pneumonia. They had breathed in so much of those soil particles that the real name of the disease is called silicosis. It hardens your lungs to the point where eventually you won't be able to breathe and you can die from it. And so dust storms, if you're ever in one, they're uncomfortable, but they also do prove to be a health hazard. So we want to try to limit stuff like this, where this soil is you know, blowing away from our farm fields. We want to stop things like that from happening. So how can we reduce soil erosion? Well, there's a number of different tactics that we can use. You can leave stubble in the field after the harvest. It's basically what's being done here. And they've harvested the corn there, but they haven't plowed this stuff under, because this stuff kind of stays on the surface of the field and helps hold the soil in place. You can also plant windbreaks. like all these trees surrounding the farm fields, what that does is it disrupts the wind, so the wind is not as efficient at picking up and carrying away the soil particles. Similar to planting windbreaks, you can do something called strip cropping. Strip cropping is where we have these crops of different heights. Like we have a high growing crop, a low growing crop, high growing. Again, this can disrupt the wind blowing across that area. Now, when it comes to water erosion, contour plowing is very effective at stopping water erosion. Contour plowing is where if you have a hill like this, you don't plow straight up the hill, but you actually plow kind of around the hill. And that's what we've seen right here. And the reason for that, if you plow straight up the hill and it rains, the plow marks channelize the water, allow the water to flow faster, and we've already gone over the faster the water flows, the better its ability to erode and transport material. So by plowing like this, we actually are slowing down the water and limiting the amount of erosion that it can cause. Similar to the contour plowing is terracing, and in terracing we actually build up flat areas, and this is done not just to create flat areas where crops can grow, but also as water runs down that hillside and it hits that flat area, remember that's going to slow the water down and stop it from having that ability to transport sediment. You can also reduce soil erosion by restricting off-road vehicle usage. Off-road vehicles, when they drive all over the surface here, they can rip up vegetation, they can churn up the surface of the soil, and that's why we're seeing all kinds of this dust blowing around. So you can limit off-road vehicles to certain places in order to limit the erosion that might be caused. And then you can just have better construction site practices. Just try to not clear off many acres of land before building structures on them. Try to keep the soil, maybe keep it wet to keep it from being blown away in places. There's many different tactics that can be used because construction sites often have extreme soil erosion associated with them. All right, in addition to soil erosion, there are other issues with soils. And one of these is soil salinization, which is a buildup of salt in soils. And what happens, this mostly happens in arid areas, so in desert areas where irrigation is used to grow crops. That's where you typically get soil salinization. So irrigation water dissolves some of the salts deeper in the soil, and the irrigation water itself might have some dissolved salts in it. And then we have, it's dry out, right? It's the desert, so we have quite a bit of evaporation. The water gets evaporated away, but whatever was dissolved in that water gets left behind. And what's dissolved in that water are these salts. So over time, salt can start building up in that area of irrigated croplands. And so in any case, this is still a problem, but it's not a new problem to agriculture in arid climates. In fact, in Mesopotamia in the 2nd century BC, there are records from one of the rulers complaining about soil salinization issues. Expansive soils are also an issue, and this is something we have right here in the Houston area. Now remember, those are the Vertosols. They contain those swelling clays. These swelling clays are minerals like smectite and bentonite, which, as I said earlier, they can absorb water, and when they absorb water, they expand 1.5 times their original size. And then when they dry out, they'll shrink back down. And this, what this can then cause is because the soil is constantly shifting as it absorbs or gives off water, the ground is not stable. And so this can crack the foundations of houses. This can crack roadways, and it also can cause pipes to break. Back in 2011, there was a major drought in the Houston area, and almost every night it seemed like the news was reporting about different pipes breaking around the city. And the reason for that was, in that major drought, the swelling clays were giving up all of their water and they were shrinking, and then those pipes were shifting around, and sometimes they would break as they shifted. And so that's one of the ways that expansive soils, while they're not one of these hazards that's going to kill you, they are a hazard that can cost a significant amount of money. And here you can see expansive soils in the United States. Red is basically where we have the most of them, and you can see there are some of these red zones right here in Texas. And so we're going to conclude Volume 2 right here, and we'll finish up soils in Volume 3.